Hi, I'm Mickael Cormier, and today I'll present our challenge on unified pedestrian attribute recognition and retrieval. This is a joint work from the Karlsruhe Institute of Technology, the Fraunhofer IOSB Karlsruhe in Germany, the Computer Vision Center and the University of Barcelona in Spain, as well as the Aalborg University and Milestone System in Denmark. In video surveillance, we often rely on eyewitness for person descriptions and thus person retrieval. A good generalization of our methods is crucial in real-world surveillance. This includes different viewpoints, varying illumination, low resolution, occlusion, attribute distribution, and camera characteristic. In our works with real-world surveillance application, we noticed that state-of-the-art methods often couldn't bridge the domain gap to real-world surveillance. Thus, we propose the UPAR-Challenge to spotlight this problem and generally give a push to the field for more research on generalization. As mentioned in the title, two tasks are addressed. Pedestrian attribute recognitions aimed at recognizing the semantic attribute of a person. Semantic attributes are soft biometric characteristics such as gender, age, or information about clothing. The second task is closely related and tries to find all the occurrences of people matching a specific attribute description. PAR is one possibility to solve this task. An important problem in these research fields is that no appropriate and realistic datasets are available. The datasets are strongly biased with respect to attribute distribution as well as image data distribution. Besides, no overarching set of attributes is annotated, which means that generalization experiments are not possible at the moment. In our other paper presented at WACV 2023, we presented the UPAR dataset. There, we addressed this topic by harmonizing 40 binary attributes belonging to 12 categories across 4 publicly available datasets. Sample images from the datasets are shown on the right. The attributes include global attributes like gender or age, but also clothing color or accessories. In total, we contribute more than 3 million additional annotation in UPAR. For the UPAR-Challenge, we again provide 0.6 million annotations for the PDIS dataset. Based on the new UPAR-Challenge dataset, we propose two generalization protocols, each of which contains multiple splits, one that uses only one domain for training and another that uses training from multiple sub-datasets. For those of you who might wonder about our notations, we use Anton as an annotation tool which is developed by Fraunhofer IOSB in Karlsruhe. A dedicated workspace, which is shown on the right, was designed with easy use of keyboard shortcuts as shown on the bottom left. We paid 16 annotators in multiple rounds of annotation and validation, which we provide with detailed instruction and discuss with them difficult cases as illustrated in the bottom of the slide. The tasks were to train with only one sub-dataset and generalize to the other, which is quite a challenging task, as illustrated on the right, the feature distribution of the different datasets. The first phase of the challenge was evaluated on data made public. The top submission has been then evaluated on private subsets, which were not known to the participants. The participants were not allowed to use different models, hyperparameter, etc. for different evaluation sub-datasets. As metrics, we use the harmonic mean of MA and F1 for track 1 and the harmonic mean of MA and of MRP and F1 for track 2. The challenge ran from the 15th of September until the 31st of October 2022 in the Codolab platform. There were two phases. A development phase with validation data and unlimited number of submissions, and a test phase with test data for which only 3 submissions per participant were allowed. We had a total of 41 registered participants. As a baseline for the challenge, we use the UPAR baseline, which is designed for generalization, but also for the specialization setting. We rely on the typical baseline architecture consisting of a backbone followed by a fully connected classification aid and apply many optimization regarding regularization and training tricks. More details can be found in the UPAR paper. Let's move to the results. MA and F1 scores belong to the PAR task, and MRP and L1 are the evaluation metrics for the retrieval. As you can see, only one participant significantly outperforms our baseline approach on track 1. No participant could beat the baseline on track 2. The former state-of-the-art strong baseline, which was not designed for this task, is given for orientation. As we can see, Team Metzler shows an important improvement in terms of AMR against the baseline. We further compare the result from Team Metzler with the UPAR baseline. In both cases, the larger the training sets, the better the results. Best results are achieved on the Pedestrian sub-dataset due to its high resolution. Metzler show consistently better result for MA and the UPAR baseline better result for F1. The image data domain shift seems to have some minor influence on general performance. In general, gender, hair, and clothing length generalize well as regularly appearing or high-catching color. Team Metzler outperforms the baseline especially for rarely occurring and fine attributes, as we can see on the image on the right. In conclusion, we contribute the UPAR-Challenge dataset for attribute recognition and attribute-based retrieval unifies 5 datasets and enable generalization experiments. Only one participant could improve against the baseline on only one track, thus there is a lot of room for improvement. Therefore, we emphasize that future research should focus on realistic scenario and generalization instead of focusing on small and biased dataset. Thank you for your attention.